All right, so our first video of 2 for our makeup day on Wednesday, section 7.2, is on sum and difference formulas. All right, and so we're going to be adding formulas, identities, to that list that you've been keeping. You have that list of identities probably on the back of your unit circle. So take a minute to pull that out. Have your unit circle on hand as well as the identity list. We're going to use both of those a lot today. All right, and I just want everybody to take a second to make sure that you've got all of these identities already on your identity list. We added a few of these last time, a few of them when we defined sine and cosine. So if you need to, pause the video and just make sure that you have all of those on your identity list, because we're going to start adding more onto this list today. All right, so the first formula that we want to add on is a formula for sine of alpha plus beta. All right, we want to answer the question, can we distribute sine over addition? Okay, so can we make this sine alpha plus sine beta? We usually use theta for our angle, but when we've got 2 of them, we tend to kick over to the beginning of the Greek alphabet with alpha and beta here. All right, so I'm going to spot check this formula, this distribution, with some angles that I know. So I'm going to write sine 30 degrees plus 60 degrees, and I'm just going to see, is that the same thing as sine 30 plus sine 60? And I picked sine 30 and sine 60 because I know sine 30 plus 60, that's sine 90. Okay, 30 plus 60 is 90. And sine of 90 I know has got to be equal to 1. That's there at the top of our unit circle. Okay, so I'm going to add sine of 30 and sine of 60 and see if it actually equals 1. Okay, so go over to sine of 30 on your unit circle. Sine 30 is equal to a half, and sine 60 is root 3 over 2. All right, and when I add those together, there's already a common denominator. I just had to add across the top and copy the common denominator. And 1 plus the square root of 3 over 2 is not equal to 1. That is not the right answer. So this question mark up here that I had, can I do this? No, I can't. We cannot distribute sine over alpha plus beta. We can't distribute it over addition. So what can we do? And it turns out that what we can do is this. It's a little bit uglier, but it actually works. Okay, so we do kind of end up distributing sine alpha, sine beta, and addition in the middle, but we also get some cosines that are thrown in there to actually make this work. Okay, so let's just spot check this with our 30 plus 60 and see if it works. So remember that when we do sine 30 plus 60, that's sine 90. And hopefully that is equal to 1. Okay, so here in the formula, my alpha is 30 and my beta is 60. So everywhere it says to put an alpha, I'm going to put a 30. Everywhere it asks for beta, I'm going to do 60. Alpha is 30. And beta is 60. So I'm just copying that formula for sine of alpha plus beta. All right, so we've already evaluated sine of 30 degrees and 60 degrees, and they ask for us to do that here and there. So sine of 30 on my unit circle was a half. Sine of 60 was root 3 over 2. But we also need to evaluate cosine 60 and cosine 30. So again, finding those on my unit circle, looking at the x-coordinate this time for cosine. Cosine 60 is, not that, it's 1/2. And cosine 30 is root 3 over 2. And then just make sure, you got these 4 numbers, make sure you do the right operations with them. These first 2 numbers, 1/2, 1/2 had multiplication between them. Same thing over on the right, and then addition in the middle. So simplify all of that with our order of operations. We'll do all the multiplication first. Multiply across the top and the bottom. 1/2 times 1/2 is 1/4. Same thing over here. Root 3 times root 3 is root 3 squared. 2 times 2 on the bottom, and addition in the middle. And 1/4 plus 3/4 is 4/4, which equals 1, which is the right answer. Sine 30 plus 60 we decided should be equal to 1 because it was the same as sine 90. All right, so this formula works. It's a little bit uglier than the first try, but it actually works. All right, so we also have a formula for sine of alpha minus beta. Okay, it follows the same pattern. You've got like this sine alpha cosine beta, cosine alpha sine beta. Those are the same. Since it's subtraction, you end up with subtraction in the middle. All right, and then we have 2 formulas for cosine. We have cosine alpha plus beta. This one looks very different. You have cosine alpha, cosine beta, so it doesn't mix and match the sines and cosines the same way as the sine formula does. And the cosine addition formula has subtraction in the middle. All right, so that's the addition formula for cosine. And the subtraction formula for cosine, again, has the same pattern as the addition formula, cosine alpha, cosine beta, sine alpha, sine beta, but with subtraction in the middle, it changes sign. The cosine addition and subtraction formulas have opposite signs in the middle. All right, so take a minute and take a minute and add these 4 sum and difference formulas to your identity sheet. You can pause the video if you need to. All right, so the 3 examples I'm going to do in this section just are different ways that we can use these formulas. Okay, so this one asks us to find the exact value of sine 195 degrees. Okay, and 195 degrees is not one of our unit circle angles. We don't have 195 degrees on the unit circle. So my hope is that I can write 195 as the sum or difference of 2 angles that I do know on the unit circle. Okay, so I need to do it with the unit circle because they've asked me for the exact value. Okay, exact value means no decimals. So sine of 195, I need to figure out, can I write that as angles that I know on the unit circle? So, you might think of like 100 plus 95. Unfortunately, 100 degrees and 95 degrees are not things that are on my unit circle either, so that's true but not helpful. I could think of 150 degrees plus 45 degrees. That equals 195, and 150 and 45 degrees, those are on my unit circle. You could also do 135, that's on the unit circle in quadrant 2, plus 60 degrees, that equals 195. Okay, and it doesn't matter which one you pick. You can use either one. I'm going to pick 150 plus 45 because I thought of it first. And I'm also going to take a second to remember my addition formula. I'm just going to write it up here for reference. My sine alpha plus beta, just copying this off of the previous slide. All right, so I'm going to take sine 195, which is what we want to find out, and I'm going to think of it as sine 150 plus 45. Okay, and then 150 is going to be my alpha, 45 is going to be my beta in that formula. So we're just going to plug into that formula, the purple formula up at the top, just plug and chug. It says sine alpha, which is 150, cosine beta, plus cosine alpha, sine beta. My goodness. Try to write this a little bit neater. There we go. And that's just asking you for 4 unit circle problems. It's like 4 unit circle questions on your test. All right, so sine 150, I go on my unit circle. 150 is over in quadrant 2. It's right above pi. Sine is the y coordinate. That gives you 1/2. while I'm there, I might as well do cosine. Cosine of 150 is negative root 3 over 2. All right, then we have sine and cosine of 45 in the formula. Cosine 45 is root 2 over 2. And sine 45 is also root 2 over 2. And again, make sure you get the right operations between these numbers. Over here, it's multiplication. Over here, it's multiplication. And in between, it is addition. All right, so order of operations, we'll do multiplication first. Multiply these fractions across the top. 1 times the square root of 2. 2 times 2. Over here, I'm going to multiply across the top. Negative root 3 times root 2 gives you negative root 6. 2 times 2 gives us 4 on the bottom. And then addition in between. All right, and those two fractions both already have a 4 in the denominator, so you don't need to get a common denominator. And then just add across the top. Square root of 2 plus a negative square root of 6. Right, and that is our answer. All right, so you can go to your calculator and type in sine of 195 degrees. I don't have a calculator with me, so I can't do it. But figure out the decimal for sine of 195 degrees. Just make sure you're in degree mode on your calculator. And then type in this fraction that we got, root 2 minus root 6, and then divide it by 4. It should give you the same value that the calculator gives you for sine of 195 degrees. Okay, so these addition formulas, subtraction formulas can give you other trig values that you can't get from just the unit circle. All right, second thing we can do with addition and subtraction formulas is to simplify some expressions, like this one, cosine of pi over 2 minus x. Okay, so this is cosine with subtraction, so I'm going to write down our cosine subtraction formula, difference formula. So again, just going back to that formula slide and copying down cosine alpha minus beta. So the cosine formulas went cosine, cosine, cosine alpha, cosine beta. And it's a subtraction formula. The cosine formulas had the opposite sign in the middle. So the subtraction formula has addition in the middle. And then the sine of both angles multiplied together. All right, so I've got cosine pi over 2 minus x. So pi over 2 is like my alpha, x is like my beta. So we're just going to plug in to that formula. Cosine pi over 2 minus x is cosine alpha cosine x plus sine alpha sine x. All right, so this time we're finding something. Not all of these are actual angles on the unit circle. I can find cosine pi over 2 and sine pi over 2 on my unit circle. Okay, go up to the top of our unit circle. Cosine is the x coordinate, 0. Sine is the y coordinate, 1. But cosine x is just a variable, so there's not really anything I can do with that, or with sine x. So I'm just evaluating the parts of that formula that I can. Okay, so it tells us 0 times cosine, 1 times sine, and all of that boils down to sine x. All right, so we've simplified. It turns out that cosine pi over 2 minus x is the same thing as sine x. All right, so these addition and subtraction formulas can also help us simplify expressions that we might run across. All right, the last question looks a little bit hairy. It gives us this information. It tells us that sine of x is 4/5, and that x is in the interval pi over 2 to pi, including pi over 2, but not including pi. That's our interval notation. Then it also tells us that cosine y, so a different angle, cosine y is equal to negative 1/3, and that y is in the interval pi to 3 pi over 2, including pi, but not including 3 pi over 2. And they ask us to find sine of x minus y. Whatever these angles x and y are, we want sine of x minus y. Okay, So all I'm going to do first is write down our formula. Here, I'll write it down with alpha and beta. If I just copy down from our original slide, our sine subtraction formula. Again, just copying that down from our identities list. There's our subtraction formula for sine. And they want us to find sine of x minus y. So x is taking the place of alpha, y is taking the place of beta. And before I make sense of all that stuff that they told us up above, I'm just going to copy that down. Okay, so sine of x minus y, that's what we're trying to find, is equal to sine x cosine y, that's my sine alpha, cosine beta. Subtraction formula has subtraction, cosine alpha, sine beta. Okay, so to find sine of x minus y, I have these 4 trig values I need to find. Okay, so let's see, they gave me sine of x. Sine of x as a whole is equal to 4/5. And they also gave me cosine y. Cosine y is negative 1/3. And I'm multiplying those. It almost looks like subtraction. I'm going to put these in parentheses so it looks like multiplication. Then they asked me to find cosine x and sine y, which they did not give me. All right, so I have to somehow go from sine x equals 4/5 to find cosine x. Okay, and the way that we're going to do that is using reference angles in triangles. So off to the side here, let's get this in a different color. I'm going to go over to my scratch work over here. All right, so I know that sine x equals 4/5. So I'm going to put x in a right triangle. So if sine is 4/5, I know sine is opposite over hypotenuse. All right, and I can use my Pythagorean theorem to figure out this other side is equal to 3. Okay, so I could say a squared plus 4 squared equals 5 squared, and then figure out that a is equal to 3. It's just our 3, 4, 5 triangle. All right, and I do that because then that tells me that cosine x is 3/5 adjacent over hypotenuse. Okay, it almost tells me that. All right, because it also gave us this extra information here, that x is between pi over 2 and pi. Okay, well, what does that mean? Oops. So on your unit circle, pi over 2 and pi, being between pi over 2 and pi, means that you're over here in quadrant 2. Okay, so they're just basically telling you that x is in quadrant 2. And I know that in quadrant 2, if I remember my mnemonic, okay, if I'm in quadrant 2, sine is positive, but cosine has to be negative. So cosine isn't going to be 3/5, it's going to be negative 3/5. So I did that so I could come over here in my formula. When they asked me for cosine x, that's got to be negative 3/5. All right, then I've got to do the same thing with y. Okay, we'll get this in. So they tell us that cosine y is negative 1/3. I'm going to put y in a right triangle. Okay, cosine is adjacent over hypotenuse. I'm going to ignore that negative for just now. I'm going to worry about the positive or negative based on what quadrant we're in. All right, and I'm trying to find sine y so that I can use it here in my formula at the end. All right, so again, Pythagorean Theorem, 1 squared plus b squared equals 3 squared. And I get that b is the square root of 8. If we're feeling super fancy, that is 2 times the square root of 2. All right, and that is the opposite side of my triangle. All right, and I did that because I'm looking for sine y, opposite over hypotenuse. Right? And I just have to make sure whether sine is going to be positive or negative, because they did give us quadrant information on y. This one they tell us y is between pi and 3 pi over 2. So just think about which quadrant that would mean. Okay, so on the unit circle, pi to 3 pi over 2 is over here in quadrant 3. And again, we care because in quadrant 3, only tangent is positive. So when I'm finding sine, again, this one has to be negative. Okay, so when I go back up to my formula here, sine y has to be negative 2 root 2 over 3. All right. So again, they told me what sine of x and cosine y was, but cosine x I figured out in my green scratch work, sine y I figured out in my blue scratch work, and now I've got all 4 of those figured out. All right, so all I have to do now is my order of operations, my multiplication. We're going to multiply these two fractions. All right, 4 times negative 1 is negative 4. 5 times 3 is 15. Same thing over here. I'm going to multiply these two fractions. I've got a negative times a negative, so it's going to be a positive 6 root 2. 5 times 3, 15. And I've got subtraction in between. So I've got negative 4. Common denominator of 15 is already there, so just subtract across the top. Negative 4 minus 6 root 2 all over 15. And that messy fraction is equal to sine of x minus y. All right, so that kind of puts together our skills with using right triangles to get from one trig function to the other, puts together our ASTC mnemonic and the addition and subtraction formula. So that one definitely has the most going on. All right, so those are the 3 kind of problems that I wanted you to be able to work with those addition and subtraction formulas. And that is all for section 7.2. So you should be able to do that homework, and I will be posting another video for section 7.3.